All right, I'm going to go through signac, and then we're going to have the first break. So the problem that signac solves, like this first point of upgraded capability, there's no special assistance from GNU Parallel for organizing your parameters or organizing your results, for giving you directories with carefully chosen names that can be used in a automated fashion. You name things manually, you track them manually, you inspect them manually, you're writing bash loops to go through a directory search or whatever you're doing. Signac is structuring the parameter space and using that to build you an organized set of directories it's deterministic given the parameters. So you can even like you can run the same parameters on a different system and you'll get a directory tree that's the same. It does not have a database. It does not have a persistent server or service component. It's just the process itself. This is using the file system as the state store. Really, you're using the NERSC file system metadata server as your database for tracking the state of your workflow. And that's like a shorthand what's actually happening under the hood for every workflow manager tool that's using the file system. So all the parameter combinations, they get their own private directory, and you can rerun things as much as you want without worrying about collisions or results clobbering earlier results. It simply notes if the output is present or not in its specified directory and then skips it or not. So this is like sort of the automatic version of needing to rerun something or not that GNU Parallel was doing with the log file. No, I forgot to have the animation there. Oh well. So signac is going to help you out when your parameter space, like the Cartesian product is much, much larger than you can do by hand. 10 by 10 by 10, that kind of thing. If you can't fit all of your run in a single job and you expect to need to chain a few together, this is going to be able to handle that reasonably well down to the task granularity. So if it's not going to be able to preserve work inside a task that's partially complete. But if you've got 1,000 parameter states to work on and you can get 300 done at a time, this will do fairly well. Aggregate results. So there is a helper function that gets provided by signac that you give it to your Python API pieces, and it will go into the directory tree itself, and it will get the things that match what you want. So you don't have to write your own directory searching and traversal and that kind of stuff with this. It gives you at least that part. Signac also has no awareness of data dependencies. Every parameter state point is independent of every other one as far as signac is concerned. All right, and reasons to upgrade. Again, it's not a DAG, it doesn't do multi-node, and it doesn't record the history. Okay, state points. So the state point is like a proper noun in signac concerns. Every unique combination, you give it your dimensions, and each dimension has all of the parameters, and then you multiply out your Cartesian project, so you're getting one point in each dimension, and each unique set of those points is called a state point as far as signac is concerned. So if you're at temperature and pressure or your dimensions, then every unique pair of temperature and pressure is going to be one state point. Oh, good. I should have just clicked earlier. Signac takes that and computes a hash to be the name, and it uses that to build the directory. And that's the portable between machines aspect. So all of the naming conventions on the file system, signac is doing that for you. And now you just need to think in terms of what are the name of my dimensions and what are the values that go into those. Yeah, and that gets stored in this statepoint.json. So the thing that you lose here is a human inspecting the file system contents. Now it doesn't really make sense because you're looking at just this big long list of hashes for directories and you don't know which one is which. The intent is that you use the signac command line interface or the Python API to actually do the lookup. So you're like, signac CLI, show me everything with temperature 300, and it'll go into the directory and show that for you. There is a big performance caveat with signac. Every state point getting its own directory, and we're looking at the Cartesian product between all of these dimensions, you're going to end up with potentially a huge number of files, directories, metadata usage. And broadly for network file system performance, if you're getting more than 1,000 files in a single spot, then you're going to start to have a bad time if you actually want to use that file system. If you try to LS that, it's going to take a long time, that sort of thing. So there is kind of a shallow ceiling on the largest reasonable size to give signac as far as how many state points it's actually going to resolve. And this is like, there's some discussion from the signac developers acknowledging this problem. And from their point of view, they recognize this as a limitation, but they want the constant speed of an access from like the lookup command to a directory. That's the part that they find the most important. And I think that might be faulty reasoning, because if you cap the total number of files to thousands, then the difference between constant or log time or whatever in your lookups doesn't matter, because it's going to be fast no matter what. Like, that constant only matters if you've got millions or billions or whatever, but you can't have millions or billions with signac. Computer science brain tangent. All right, so if you really want to have a big parameter sweep, there are some other tools that will do a better storage on the file system arrangement. Like, you can do nested directories that fan out further. And there's some tools that do things like that. Like Nextflow does that. Pipette is like a Python API piece. DVC is not necessarily a workflow management tool, but it solved this specific problem. And Ada also has a better system for organizing the stuff on disk and not incurring too much metadata load on the file system. All right. Creating and exploring jobs. So this code here, this is in Python API terms. We're talking about like import signac, and then we're calling things in that. We're not doing bash CLI at this point in time. So there's an init command that will prepare the initial infrastructure to want to make those directories. And then you get an open job and you pass it the dictionaries, and that actually gives you your workspace directory where all of your state point directories are going to live. You can rerun this stuff without worrying about like collisions or problems that way. And there are some CLI tools for show me the names of my dimensions and the range of values and that sort of thing. Find a specific thing. Yeah, these ones are Linux commands, not Python API commands. Okay, now this signac view, that's a little interesting because that's going to give you a second directory tree containing symlinks, and the directory names are going to be sort of your dimensions and values. So you can inspect that in like the file system, ls, whatever interface and see something that makes sense to a human. But it's still going to be symlinks back to the actual data in the hash name directories. And that's going to use a lot of file system inodes if you've got a really big thing. So that would be like a quota thing to look out for. And without going back to look at it, I will note that the first signac example doesn't actually run any compute. It is just setting up the directory, and running and using it is being used in later examples. So don't be like looking in the first example for where the results go, what's going on. It's because they haven't been run yet. That's just preparing the workspace. All right. Flow project. So signac itself is actually incomplete. You set up the directory and you get like this one command that is the, I tell you my dimensions and characteristics I'm interested in. You show me the directory. But like that, you would have to, write your own bash scripts and Python scripts using that to actually turn this into something that does useful work. Signac Flow is the sort of operational component that, actually take that utility piece and give me something that will turn this into Slurm jobs, will turn this into something that I can run locally, that kind of thing. All right, Flow project. Yeah, so this operation decorator, you add that to a Python function to define it as, this is the actual computation that I want to do for each state point. And you can give it information about the resources that you want to be used. This is information that's going to be passed to Slurm. I do not know the units of wall time off the top of my head. I think this is an hour, so I think this is going to be 30 minutes, but I am not 100% sure about that. I expect there would be a question in somebody seeing this, but NP one node. So this piece is the bridge between what you're writing in your Python script using Signac Flow and what's actually going to happen in Slurm when you run it. So that function is going to get called for each state point. So without Signac Flow, you actually have to write your own sbatch scripts or do something with a loop and parameters to turn the Signac directory parameter suite into running work. And in this way, a large part of that, instead of writing that Slurm script, you're defining things in Python with the API. And a thing to look out for here, you would rather that these be larger tasks. If you take 100,000 state point Signac Flow and you do this exactly, you're going to have a bad time. You're going to run into like job submission limits from Slurm and that kind of thing. This is really much better suited for smaller total numbers of state points and larger individual submissions. This is not going to this is not going to batch things together into a single Slurm job. It's going to do individual jobs for state points. All right, so the label is the equivalent of the exit code 0 in GNU parallel. Is the result present or not? So, you've got to check to see if results text is there, and then you put the decorator on it. And that's how you end up with the same functionality as GNU parallel as far as logging and resume failed. And here's the submit. So pretend is the equivalent of doing a dry run. So that'll show you all of the actual Slurm scripts that get run for whatever you happen to have written in project.py. And remove the pretend, and it will actually do the submission. Because we've got some special parameters today with like the account, and we need to pass in constraints, this double dash is like a specific functional thing in signac for turning the parameters after it into additional SBatch arguments. So that's how you get extra things like the train reservation or whatever to the SBatch command. So now that the actual compute has been run for each state point in the signac parameter sweep, you get access to a query syntax that lets you search through, filter, scan out pieces of that, and actually do work with the parts that you're interested in. So you can find jobs based on filters, and you'll end up with this object that has just the matching jobs that you want. So if I want everything that had temperature 300, that's the filter dict that you pass through. Here's you can give things that are greater than 400 or equal in a subset or a list, or you can just have it, give me all the jobs in an object. So these queries are running on the file system, not in a database. So again, what they're actually doing is they're using the nurse metadata server as the database. Okay, so let's see. For every job in project find jobs with whatever filter, do you have results.txt? If you do, open the job, and this job.function there, that's going to give you the absolute path. So now we've got the file open, the results.txt for whichever job we're looking at in the loop. That job has this state point accessor, and that'll give you access to the temperature, the pressure, or whatever. So that's how you get the details of whatever parameters actually went into those results. Yeah, and so now you have an API access into your signac results that is shaped like the parameters that you put into it, and it's not shaped like the file system and file system names and Linux commands for acting on the file system. Yeah. You also have a lot more flexibility for changing parameter names or changing your queries without going back and needing to do work in the file system. And you can chain together your queries much more easily than if you were doing file system operations. Okay. Review of where we sit in how we're moving from simple tools to complex tools. So now the parameters and the state points, the sweep is being organized for you on the file system instead of needing to do that yourself. You haven't added data dependencies between steps. You haven't added multi-node yet. And we haven't added that history record or usability. Yeah, no. So the query API could sort of be used as provenance. Like you have very powerful access searching through what ran, but you still don't have things like software versions or input files that went in or something like that. Information was lost once the run was completed. So we're not tracking everything, but you have more information about what ran than you do in otherwise. All right. And review of vocabulary for signac. So state point, one unique combination of elements in your parameter suite. The directory that has all of the state point directories in it is the workspace. Job from signac perspective is each one of those directories maps to one job, one piece of compute that goes with a particular state point. The hash or job ID is that identifier that gets used to make the directory. Label is the function that tells you whether your job was finished or not. Operation is the decorator that you put on a function to mark it as this is the computation for what you do with each state point. And post condition is the label that you use to check whether work has already been done or not and can be skipped.